So today we are going to solve this question, which is a combination sum 3 problem. Combination sum 3 problem that where we have a given basically k, which is 3, and we have given n basically which is a kind of target. So we have to return all the possible combination which will add up to this target, and it has decided k numbers. Like here the k is 3, so we have over here 3 numbers over here. So we have to generate all such combination which will fulfill this condition, these two conditions, which is which is the sum should be equals to n, and the number of element in there should be equals to k. So over here we can see that there is only a usage of numerals, so we can use only numbers from 1 to 9, and only we can use each number at a single time. This is the two condition we have given. So in order to generate all the subsequences, or I would say like all the different combinations, I can think of a recursion to generate all of them. So if I draw a recursion diagram on my paper, so basically we have given over here 3 and n equals to 7. So at first I have nothing, so I have to choose 3 elements in order to get the sum equals to 7. So how will I start? Like I will start like I can choose from 1 to 9. I will choose 1, I will choose 2, I will choose 3, and I will choose 4. I will choose all this till 9, which is given to me. If I choose 1, then I will have like target will be 6, and I have 1. And if I choose a 2, then I will have a 2, and I will have a target which is 5, basically 1 less than it. And if I choose a 3, then I will have a target basically 4, and if I will choose a 4, then I will have a target which is 3. So likewise I have a different set of branches, and in the one, if I go more than in the one, there could be a more branches of a recursion, where I will say like I will choose 1, and I will choose after that 2 from here. Similarly, in the third branch after 3 I will choose 4. Over here, when I choose 3 in a level 0, I will not choose here 1, because that will be taken care by this particular branch which is over here. It will definitely have 1 and 3 over here, so this will kind of a duplicate. So in order to avoid this kind of duplicate, once I have vested 2, once I have started with 2, I will go after this, like I will choose from 3, 5, 4, 5 likewise. So it's basically to avoid the duplicate case. Once I am started with 4, then I will go further, like I will in the below branches I will start from the 5, 6, 7, not below the 4, in order to avoid duplicate. So this is the recursion tree which will be there. So it is basically a multiple branches recursion tree, which will give me all the possible combination of it. So let's talk about the base cases over here. The base cases over here will be simple, like if I reach at the end, like not end, sorry, if I reach the target equals to 0, if my target is 0 after picking up all the different set of elements from 1 to 9, and my length is equals to given k, my length of this is equals to given k, then this, if I hit this base case, then I have picked up the valid combination after in the recursion tree. So I will put it in the ALS, I will put it over here. This is the one base case, and other base case will be over here, like if my target by any chance go below 0, which is like in the combination I have picked up such elements which will give me a sum more than the 7. So over here this is not valid, and other thing is that I have picked more elements, like basically my elements is basically greater than given elements, so this is not a valid case, so I have to return from here and do not put over here anything. These are the two base cases which I can think of for this problem, and apart from that I will simply write a recursion with the for loop, because I have literally 9 ways from starting to pick elements. So I will write a for loop for 1 2 3, all these 9, all these different branches, all these different branches. So yeah, I will write the for loop from starting, because in from the starting I have a 9 different branches, 9 different ways to pick up the element. I will start from 1 2 3 4 5 6 or 9. So this is the starting point. I have 9 choices, so I will simply use the for loop over here for this initial condition. So let's go to the code and write it down. So we are here, so let's go over here to write the code for combination sum 3. So what I have, I should have ALS, fine. I should have current, which will store all the small or different sequences over here, fine. And we, as usual, index to iterate, okay, it is fine. Let's call this n equals sum, this n call this sum, or maybe target, like sum is fine. And yeah, these are the things we have. Let's call the function this dot get combination sum 3, this dot get combination sum 3, combination sum 3, over here ans, over here print, over here sum, over here fine, k over here fine. And I have to pass the index like 0, no index is needed over here, because we have to iterate through 9 branches, so there is no given arrays. So yeah, this is the way. And then this return ans over here, which will store all the different valid sequence for this problem. And over here simply write this function, recursive function, which will have ans current, will have sum over here, it will have k over here fine. Now at first just write the base cases, like if my length like first base case to for the valid sequence, what it will be, like if my sum is equal to 0, and the length which I have given to me is equals to given current array element length, this is a valid case, basically a valid subarray. So I will put this subarray into this answer variable, return from there. And other base case is a base case to handle other base case to handle the non-valid subsequences. If by any chance my sum goes below 0, or my k length, or my current array length is greater than a given length, this is invalid case, just print from this, because this is invalid. Just and these are the two base cases for this problem, and I will write now the recursion thing, because I have 9 branches from the starting, so 9 possible ways I can pick up the elements. So let's write it. It's I equals to 0, not 0, I is less than equals to 9, I plus plus, it will go till from 1 to 9. And I will add here a check if my current element, which is what I have picked, like 1 2 3 4 5, whatever that I have picked is less than or equals to given sum I'm carrying right now. If my suppose like I have n7 and I have picked over here 9, so this is not a valid case. So if it's 6, then it will be a valid case. So this is the thing I have to take care of. If I pick up the element which is less than or equals to 7, so this is the valid case. Simply call the expression this combination sum 3 fairness over here, current over here, and sum plus basically sum plus I, and over here k is there, k is there. Okay, at first I just have to put it in the current dot push I. So I will push the given I element in the current array. Then I will call this recursion where I will add up to a sum, and the k will be as it is, and y, and there's a step of backtracking over here, and there by any chance this is false, then like we have like by any chance this condition not met, that means we are working on an invalid sequence. So in that case just simply break. When we break it, then it will goes over here and return from here. So yeah, this is the thing. Let's go and submit it out. Okay, like we got your output wrong. Let's see what we have done wrong over here. Over here, if sum equals to 0, okay, basically I'm doing whatever, like I have to subtract it. Okay, I'm getting a lot of different 1 5 6 7 5 6 7. Okay, I need with this one, like if curve, this should be equals to this, curve dot length should be equals to this, 5 6 7 5 5 6 7 5 6 7, no other valid combinations. This is repeating over here. Some or current dot length current dot push. Okay, I have to use element. I have to use element at a one time, like it should not repeat it, like over here I've seen a repetitions which is not good. So okay, 5 1 1 repetition, 4 2 1 is repetition, 4 1 2 is repetition. I've seen a repetitions over here, so I have to avoid it. Like I'm getting from 1 to 9 over here, 5, and So this is also very important. Like this will keep this start will keep a track of avoiding the duplicate which I was talking about and I missed it. Like suppose in the first level, like in a level 0, I am starting from 1. In the same recursion multiple branches, I have to start from 2. In the same branch I have to start from 3. So this will keep a track of